For our senior design project, we had a solar charged Bluetooth car. I'm Tristan, the team leader.
I'm Ashley, the spokesperson.
Chris, digital hardware design.
And we have JR recording. So what we did for our first test document, we had make sure our controls test was integrated, and the integration test will verify whether the Arduino will provide strong connection to control with no interference. That's the engineering requirement. It will meet the Arduino technology will utilize the car, and then Class 2 Bluetooth receivers will connect to the car, and also the car will be connected to one controller at a time. The setup of this test is the program code should be loaded onto the Arduino board. The controller should then establish connectivity with the Arduino board. There should be very minimal distance and no object between the controller while connecting is established. After connection is established, the controller should be moved around varying distances and objects in between the controller and the board. The Arduino board should be connected to a computer to monitor communications. So first in our test, we have connect the Arduino board to the computer and download code to the board, which has been done.
You have the controller.
Oh.
Alright, the code's been downloaded to the car. Use control buttons, like as he's doing. So now varying distance in between the controller and the board. Nah. Also, we have saved the recorded data into a spreadsheet already, and each one of our setup actions have passed for this.
Every 6 months. Just additional. But then I would have account for that in the.
So the second test document utilized our solar panel unit test. We made sure it was solar panel to verify it would apply enough voltage to the battery and didn't amount to light. What we did when we did our circuit, we made sure that it was outputting about 10 volts, 9 to 10 volts, because the light would vary on the solar panel. So we made sure the circuit didn't back discharge using blocking diodes. So for the setup test we did, make sure it put out enough energy. We did read the voltage under direct sunlight, and read it under room light, covering different portions of the solar panel. First covering none of it, 25%, 50%, 75%, and all of it. And just by each time we had enough voltage to control the car, but will charge the battery, but not when it was completely covered. The next test is our durability test. Durability test will verify whether the car and the system components are completely operable after impact with a stationary object. Engineering requirement, at the car's speed, the solar panel will remain operable after impact with stationary objects. So setup for this was connect all system components to the car, select a stationary object, drive car into stationary object, check the operation and components of the car. Alright, that's our demonstration for the car. We showed you the connectivity test, the control test. That's the integration test, making sure that it connects to Arduino and Bluetooth technology as it's connected to the PS3 controller. And the other test document we used was the solar panel. Make sure we did that outside also when we presented to Dr. Lee a few times actually. And it showed that the solar panel put out enough voltage to actually charge the battery of the car and the microprocessor. Then we actually showed our durability test, made sure that it was operable after running into stuff, you know, it's pretty good. And that's the solar charged Bluetooth car for our senior project.